So this is a pretty straightforward problem, at least in how we approach it. It can be a little bit trickier here in a minute, but if I'm doing f of 3, then that's going to be 5 times 3 squared minus 7 times 4 times 3 plus 3. All right, so all I did was substitute 3 in wherever I had an x. And maybe the first part of this is where some people got off. So what we want to do first is we want to do 3 squared. And so that's going to be 5 times 9. So you do the x squared first. So 3 squared. And then anyways, it's going to be minus 7 times, and I'll just do the 4 times 3, which gives me 12 plus 3. So I'm going to do this in a number of steps. Sometimes people do this in like combining multiple steps together, and that's okay. 5 times 9 is going to be 45 minus 7. 12 plus 3 is 15. Now I can just do the 7 times 15. So 45 minus 7 times 15. You probably want to plug that in your calculator, but that is 105. And then when I do 45 minus 105, I get, negative 60. So your answer is D, actually. And hopefully you can see this is the benefit of actually doing the work. Because if you wrote down and you were doing the math on a piece of scratch paper next to you, and then now you see what the correct answer is, you can see, hopefully you can identify where you made your mistake. Like anything, and I repeat myself a lot with this, if any of this is confusing to you, you can stick around. We can go over it in more detail. That includes all the actual content that'll be in your test and this stuff as well. Keeping in mind that on your test, I'll probably always have just some basic math skills on there, like solve this equation, simplify this radical. So that's always going to be present. All right, so as far as today goes, we're going to be just getting some practice with the rules that we used yesterday. It's not just those rules. So we learned 4 new rules. We learned about the triangle sum theorem. I'll just write them on the screen real quick. The triangle sum theorem. We learned about the exterior angle of a triangle, the base angles of an isosceles triangle, and we learned about equilateral triangles. And so those are the 4 acronyms or abbreviations that we learned for that. And we are going to be referring to those primarily today, but we could also be using other angle relationships, angle rules that we learned in the past. So at this point, we have 14 angle rules. I might be thinking that right. And so, I mean, if I just wrote them all out real quick, we have our vertical angles, linear pairs, angle addition postulate, which I'll put a star next to it because we don't really use it that much. There's the angles at a point, angles on a line, and then we have our corresponding angles. We have same side interior, same side exterior, alternate interior, and alternate exterior angles. So when I say those, if you can already imagine what all those angles look like, then you're in good shape. So we kind of learned it in 3 chunks. And today is going to be primarily this stuff, but it will refer to this stuff a little bit as well. It doesn't, okay, let's just jump into it. So those are all the rules. And now to keep that straight, all right, so there's not a whole lot going on with the bell work today, or sorry, with the presentation. If I come over here, let me go back into the modules. I did add a new reference sheet for you. My internet's going a little bit slow, but here we go. This angle rules reference sheet. Now there was this already here before, but I replaced it. This is a different PDF. And if we look at it, this will be a good thing for you to have available as you're going through your work individually. Now, if you've got everything memorized, you're good to go. But notice that it just simplifies it a little bit. We've got the names of the rule on the left, and then you've got your abbreviation just to make your life a little easier. And of course, that's what I write a lot of the time. So if I say AEA, you need to know that's alternate exterior angles. And here's an example of those. And then here's what we know. We know that if we have A and B right here, that angle A is equal to angle B. So these are the equations that we use. And this is kind of the key part of it. So I can take this diagram right here and I can create an equation out of it that looks like that. So we're always trying to convert a geometric diagram into an algebraic equation so we can actually do our algebra and solve for whatever missing value we're looking for. So that's available for you. And if I go back here to modules, you can see that right here for your assignment today, we've got two different things for you to do. So we're going to look at homework 1 and homework 2, and I'm going to go through part of it, but not all of it. Well, anyway, I don't know what I'm saying exactly, but you know, some of it you'll just have to figure out. And I just wanted to point something out real quick. If you have not been coming here, when you go to, like, this is, was that last Friday? This is last Friday's class. I record videos and I post them here. So if you ever need to go back over what we did, you get to hear me twice. So just a reminder, it's always good to go through this. And look at that, that's exactly our class on Friday. So that video is posted. So if you're ever trying to go back and review anything, I encourage you to come back and find that day's date and you can review what we did. All right, that's enough with this. I'm actually going to change what we're looking at. I need to get my stuff sorted out. The first thing we're going to look at is not part of your homework. So let me pull this up real quick. Okay, and one thing we didn't really look at yesterday was the two other rules. We looked at the triangle sum theorem and we looked at the exterior angle of a triangle, but we didn't look at the other two rules. So I wanted to show you what that looks like in practice. All right, so let's look at this right here. And what kind of triangle are we looking at with this diagram? Does anyone have a name for that triangle?
Equilateral.
Very good, equilateral. So knowing that this is equilateral, if you remember the rule we learned yesterday, what is the measure of angle D going to have to be?
Would be 60.
60 degrees. It is that. And just as a reminder, because we didn't look at it yesterday, so I can understand if you forgot. But remember, since all three angles in a triangle have to add up to 180, and because this has three equal angles, basically all three angles right here are the same as angle D. So I have 3 times D equals 180 degrees. So if I divide by 3, each angle D is 60 degrees. So it always will be the case that an equilateral triangle has 60-degree angles at every corner. Okay, so that's kind of a straightforward problem. We could make this more difficult, but basically that's what we've got going on. All right, now we're looking at what kind of triangle for these two problems. Do we have a name for those types of triangles? So I'm not asking for the angle rule right now. I'm just asking you to name what type of triangle that is.
Isosceles.
That's it, isosceles. We've got 2 congruent sides for both of them. So that means that it's isosceles. We talked about that just a little bit in overview. All right, so we do have a rule which abbreviates to this: base angles of an isosceles triangle, which says that, what do we know about these two angles, A and B?
They're going to be the same.
That's absolutely right. Good job. Thank you. So the measure of angle A is going to equal the measure of angle B. And this is what we can use moving forward. Now, I'll run through this problem number 1 real quick. So if I know that this is my missing angle and I'm trying to solve for A, well, luckily the base angles theorem right here, base angles of an isosceles triangle, tells me this angle is going to be exactly the same. So that's also going to be A. And at first it might not look like we made any progress, but now let's kind of figure out what's going on. So if this is angle A on the right, and that's angle A on the left, now I have 3 angles and I can put this into an equation and we'll see how this works. So 20 degrees plus A equals 180. I could write the measure of angle A. I'm just being a little bit lazy. And if you wrote it like this, that's not the end of the world for me. So 20 plus A, well, I can just combine my variables together. That's 20 plus 2 times A, and that's 180. And now maybe you can see where we're going from here, if you weren't able to see it before. So this is just a straightforward equation. I'll finish solving it. If I subtract 20 from both sides, I get 2A is equal to 160. If I divide by 2, then I can see that A is going to equal 80 degrees. So by using that theorem, I can now show that this angle has to be 80 degrees. Okay, so I kind of ran through that one. I want you guys to kind of chip in and let's see if we can get some more people talking. I appreciate, Allison, everything that you're saying, but let's see if more people can jump in. So for this next one right here, what can we do first? Is there any angle in this diagram that we can right off the bat say we know what the angle measure is?
The 20 degrees.
So it won't necessarily be 20 again. It was 20 that first time around. Sorry, we're now looking at the one on the right. So it's not actually going to
Oh,
be.
sorry.
No,
65
you're fine.
degrees.
There you go, 65 degrees. And we're looking at this angle down here. This is using the same rule. And if, I should point this out right now, if you see an isosceles triangle in a diagram, you will be using the base angles of an isosceles triangle theorem. That will come up somehow. So in this case, because this is 65 on the left, that's 65 on the right, and I can say that's because of the base, if I can write this correctly, base angles of an isosceles triangle. That's a rule I used. So now, what could my next step be if I'm trying to solve for this angle up here?
You could add the 65s together and then subtract it from 180.
There you go. So I'm going to write it this way, 65 plus 65 plus, I'm just going to call this angle X. You're going to see in a minute, we're going to do some problems. I'm just going to throw out the missing angle X a lot. All right. So that has to add up to 180. And this is because of, what rule would we call that? Does anyone remember the name of it? It ends with a T.
Triangle sum theorem.
There it is. My next clue is it starts with a T, TST. That's just to get you guys thinking about the names of the rules. I'm trying to get you some practice just using the rules right now, but tomorrow we're going to get some more practice with naming the rules, okay? So if you knew you were supposed to do this, maybe the next step is just to be able to say, this is because of the triangle sum theorem. All right, I'm going to quickly solve this one, and this is going to be 50 degrees. All right, so if you need to go through the algebra, you can do that, but I just wanted to show you, we can solve with triangle sum theorem to get that's 50. So what does that mean that B has to be? Does anyone have an idea what angle measure B will be? Or what we can do to solve for it?
Would it be 310 degrees?
It will be 310. All right, so I can say that B plus 50 is going to equal 360 degrees. And I know that because I'm just going to give you like 10 seconds. Anyone know the rule that we're using here? This is angles at a point. Because we have, in this case, it's only two angles, and that's okay. We got two angles that are going around a point, and we get 360 degrees out of it. So bottom line, just to wrap this up, B is going to be 310 degrees. All right, so I wanted to show you a little bit of that today. And I decided that tomorrow and Monday are just going to be review days. So you have learned all the content you need for this next test. You're going to have 2 more days, including today, of just practice. All right, so if you are not 100% there today, that's okay. You have 2 more days, including the weekend. You can look over some stuff to try and nail the stuff down. All right, now let me change what we're looking at. I'm going to pull up another page. This is your homework number 2. We're not actually going to do any problems here, but if it helps you, you can do this top part. Look over it, and you don't have to do this as part of your homework, but I highly, highly encourage you guys to do this. We might do this in class tomorrow, but I highly encourage you to look at this, see if you can name the angle relationship shown in this diagram. Down here, you need to do problems A, C, and E. And so these are reviewing the rules that we learned on Monday, and we spent Tuesday practicing them. So this is your practice from Monday and Tuesday, and that's all I was really going to show on this page. And now, let me pull up what we're going to spend the rest of class looking at. Okay, everyone's looking at this now. Your homework for tonight on this is going to be to look at these problems and these problems and solve all 8 of those. So I'm going to take a little bit of class time to look at the other 8, though I'm only going to do like 3 or 4 problems. All right, and the first ones I'm not even going to look at in great detail. So I'm zooming in right here to 17 and 19. Now this is one that if you did the homework last night, this is exactly like one of the types of problems you would have seen in your homework. So I'm actually not going to spend any time with that. If you don't know what to do here, then go to that Delta Math that was assigned yesterday and look at that some more. I mean, I can walk through this one if you want to stay on the Zoom chat, but I'm not going to do it right now. So number 19, the first thing I kind of want you to get into the habit of doing after you mentally, or if you sketch this diagram on your page, after you draw some arcs here, I want you to try and figure out which rule are we even using to solve this problem. And if you did this, the last night's homework, you should be able to recognize what we're looking at here. Does anyone have a name for the rule that we're using here?
Exterior angle of a triangle.
That is great. That's exactly right. Exterior angle of a triangle. And what that says is that this angle right here is your exterior angle. It's outside the triangle, but I just extended one of the sides of the triangle over. So this angle, 97 plus x, has to equal the two opposite interior angles added together. That's gonna be 64 plus 27. I just wanted to quickly do this one, and actually that's as far as I'm gonna go with it. The key part, like the hardest part of this entire thing, is identifying what the correct equation should be and setting it up. Once you have that, it's just algebra. And every one of you should be able to do this. So anyways, I'm just gonna call that one good for now. If you wanna have that written down, this isn't one you have to do for homework, but it's good for practice to look at that. Okay, so we have these other problems down here. These might give you some grief, but it's really not that bad. And anyways, we can look at those more if you want to, but I'm not going to do any of these problems right now because I wanted to come over to these. And these look complex. And I won't lie, it can be very intimidating. So you're going to do this problem right here for homework. But this one over here, they almost use the exact same diagram. So if I can do the one on the left, then that'll give you some ideas of how to do the one on the right. All right, so that's what I'm gonna do. I'm gonna start off this way, and I'm just gonna run through this first one myself, and then the next one, I'm gonna try and get you guys to chip in a little more. But for this, I want you to make sure you're paying attention. All right, so you can follow my thought process. I'm gonna change my colors along the way so it's color coded. So the first thing for you guys to know is that if this is our missing angle over here, generally speaking, we're gonna have to start on the opposite side of the diagram. So I'm gonna have to start over here somewhere. And then I'm gonna have to work my way that direction until I finally solve for the question mark. All right, so if I have to start over on the left side, I'm looking for any angle relationship I can find. Hopefully some of you are looking at this and saying, I already know what to do. And that's great if that's where you're at. But if you aren't seeing it yet, I've got this 45-degree angle right here. And look at that, we've got vertical angles. So I'm gonna go ahead and show that real quick, that these are vertical angles. And what vertical angles tells me, I'm gonna call this X real quick. That tells me that X, the measure of angle X, is gonna equal 45 degrees. Opposite angles are congruent. So I've got a starting point. So I'll just go ahead and I'm going to replace this X right here with 45 degrees. So that's step one. And notice how I'm actually showing the angle relationship that I'm using. All right, now the next thing I can do is I can hone in. I might have to look at this for a minute or two, but hopefully not, maybe just a few seconds, hopefully. But then I can look at this and I can notice that there's this triangle right here, and I've got two of the angles. So what I want to do is I want to solve for that angle using these three right here. So that's now my new X. And so this is going to be an example of using the triangle sum theorem. And what I mean by that is that these three angles have to add to 180. So it's going to be 60 plus 45 plus X equals 180. So if I go through and solve this, that's going to be 105 plus X equals 180. Subtract 105 from each side, X equals 75. All right, so I will erase this and replace it with 75. And I need to keep moving forward. I've got a good next step, but again, I might have to now look at it for a few seconds, try and figure out what to do next. And here's what I figure out. I've got these three angles right here all form a line. I'll put an X right here. And so this is a good example of angles on a line, where all three of these have to add up to 180. And again, you might not notice it immediately. You might have to sit there for a little bit, go back to your reference sheet, look at all the different possibilities, and then you kind of say, no, it's not vertical angles, it's not alternate interior, you just keep ruling everything out until you finally look at it and say, oh, you know what? That looks like angles on a line, perhaps. So now angles on a line tells me that these three angles, 75 plus 68 plus x, have to add up to that line, which is 180 degrees. This looks like the same equation we just did, and in practice it is, but we came at it from a different direction. We're saying this is angles on a line, and now I can still solve it the same way. So when I add these together, that's going to be 143. And now I can subtract 143, x equals 37. So again, I'm just going to keep adding these new angles on here whenever I solve for them. So that's 37 degrees. And from here, I've got a couple of options. Now I'm going to show you the fast way of doing this, and you might not notice it this way. But this is my angle I'm trying to solve for. And if I rotate this diagram, so I'm going to kind of show this diagram rotated around. Here's the unknown angle x. Here's my 37 degrees. And here's my 100. If you can kind of rotate that about, what is that, about 90 degrees clockwise, you can see that it's the same diagram. But now what this is, it looks a lot clearer maybe in this direction. What we're looking at is this is the exterior angle of a triangle theorem. And so that tells me that my missing angle x, I'm going to put the measure of angle x here, equals 100 plus 37. So when I add that together, I get the measure of angle x is 137 degrees. I'm going to put a double box around that. That's my final answer. Okay, so I want to pause right there. You can take a picture of this as a screenshot. Does anyone have any questions on this right here? Okay. Now what I'm going to do, again, you can take a picture of this. This is kind of the fast way of doing it. But let's say that we did not notice that exterior angles. So I'm going to erase this part of it only. And I'm going to show you one other way you could have looked at this problem at the end. And maybe some of you in your head were already looking at it this way. Let me get rid of that. So let's say that you didn't think you could immediately solve for that x, and instead you did this. I know these two angles, I could solve for this one right here. This is my new x. So I'm going to start by doing triangle sum theorem. And now I've got 37 plus 100 plus x equals 180. And that's going to give me 137 plus x equals 180. And x equals 43 degrees. So using this, I got 43 degrees right here. And then at this point, we're not done because that's not my final answer. So I'd have to do one more step here, and I will go back to red for this. At this point, maybe we notice this is what we call a linear pair. So now what my linear pair rules tells me, and this is where you want to have your reference available because I don't expect you to have this stuff memorized. But I know that linear pairs are supplementary. So 43 plus the measure of angle x is going to add up to 180. So if I subtract 43 from both sides, my measure of angle x is going to be 137 degrees, which is what we already got before. We just did one extra step to get there. So there are multiple ways you can approach this problem. And honestly, there are multiple ways we could have done this that I'm not even showing you. But that's the basic idea. We have to use all of our angle rules to work our way through the diagram. And this might be very daunting at first, but I really want you guys to try it. If you want to come back to class tomorrow and say, can we please go over number 14 or whatever, then we can go over that. But you need to try this stuff first. I'm going to go ahead and erase my screen. If you want to get a screenshot, I'll give you about 5 more seconds to do that. And actually, I'll leave this up there for a little bit because I need at this point everyone to raise your hand. So like I was saying, if you were able to follow along with this one, problem 16 and problem 10 should be pretty similar to it. Problems 12 and 14 have this almost figure 8 pattern going on. So what I'm going to do is I'm going to look at problem number 9. I'm going to skip 11 and 13, but if you want to see how to do those, we can go through those as well. But I'm going to do number 9 because those, if you can do problem 9 and problem 15, then you should be able to work your way through these 4. So let's just focus on that real quick. And one of the first things you might want to do, and this is going to be tempting, but with a problem like this, you might be tempted to say, oh, these lines are, oops, moved on me. These lines are parallel, but they're not, all right? So in some cases, I'll try and make it very, very clear when the lines are parallel, but that is not the case with this, so I'm going to clear all that. They're not parallel, so we can't use any rules related to parallel lines. That's okay, we have other methods we can use. So now let's see what's going on. I have to start, since this is where my unknown is, I'm going to have to start at the other side of the diagram and work my way toward it. So I've got 20, 40, and I'm already seeing something here. This is a triangle, so I should be able to solve for this angle X using the triangle sum theorem. So at this point, 20 plus 40 plus X have to add up to 180 degrees. So I add this together, 60 plus X equals 180, and then subtract the 60, X equals 120. All right, so I'll erase that real quick, and I get 120 degrees for that angle. All right, we're ready to move forward to the next part. So if that's 120 degrees right here, then I'm already seeing something. These vertical angles show up all the time. I meant to have you guys jump in on this. So sorry, I already said it. Vertical angles. So what is our angle up above going to be?
$120, right?
120. They're identical. So I'll go ahead and write this off to the side that we're using vertical angles, and X is going to be 120 degrees. That was my X. And again, you'll notice I just keep, anytime I have a new problem, just keep using a brand new X, and that's fine with me. All right, so that's going to be 120 degrees. So now, what is the last thing we can do to solve for an unknown angle?
You can add 39 and 120.
There you go, 39 and 120. And then that adds with, I'll go and show this, it adds with that. What rule are we using for this?
The triangle sum theorem.
That keeps coming up. Thanks, Hope. All right, so we got triangle sum theorem. I'll just write it right there. These do all add up. 39 plus 120 plus measure of angle X is equal to 180. And again, if you're wondering where I'm just pulling this equation out of, if it seems like I'm making this equation up and you don't know where it's coming from, remember we have that reference sheet, and maybe I'll just quickly, no, I don't want to, sometimes I can screw things up if I go over there. But anyways, let's finish this calculation and I'll show you where this came from, just in case you're still confused on this. I didn't just make this up out of nowhere. All the angles have to add up to 180. So anyways, when I add this together, that's 159 plus a measure of angle X. So now if I subtract 159 from both sides, the measure of angle X is going to be 21 degrees. Put my box around that. So there's my final answer. Okay, I'll leave that up there for a second for anyone. If you want to get a screenshot of it, you might use that for reference later as you're going through the other problems. Okay, and then just the last thing I wanted to show you, like I said, if you are confused on where these equations are coming from, I'm going to clear my screen now, and I'm going to go back to Canvas right here. And I'll go back to the angle reference sheet. This is something you're probably going to want to have available that you can quickly pull up if you need to see it. But when we're looking at the triangle sum theorem, that's showing up right here. And notice I take my three angles A, B, and C, add them up, set it equal to 180. So that's what the equation is. When we did the exterior angle of a triangle, I took these two, added them together, and it equaled the exterior angle. So get comfortable with using this. And at this point, if you have any questions on anything, please stick around. I know someone already indicated they're going to stick around. But if you have questions on anything, if you want to go through another problem, just let me know. And otherwise, you know what your homework is. It's on the Canvas page. I encourage you to get started on that right now. And have a wonderful day. I will see you tomorrow.